Alrighty, so the experiments that we're going to be working on right here inside the content folder are these 3 rigid body experiments. So the first one that we're going to go over, this is basically just how to get objects to interact with the gravinol, adding the rigid body component, as well as going over some physics materials, how those interact and how to apply those. So here in Unity I have my 2 scenes, right? I have my hub and my rigid body scene that I want to work on, so I'm just going to make the rigid body scene my active one. Alright, cool. So first things first is I want to show off the difference between using a level blocking mesh and using an actual game object that Unity creates. So in here I'm just going to create 2 cubes. Alright, so remember when we talked last time, back in the first week, about these level blocking meshes, I told you about the pivots, right? How the pivots are set to the corners of the object, and the Unity ones are set to the centers. So this is important because when the gravinol picks up an object, it's picking it up from its pivot point. So here we go. I have 2 objects, and I'll showcase, why you'd want to use one and why you wouldn't want to use another in certain cases. So to get things to interact with the gravinol, you need to do 2 things to the object. First things first is you need to add a rigid body component to this object, right? So the rigid body component is definitely used in a lot of cases, and it's important to understand why you want to use this, right? Why this piece of functionality is useful on certain game objects and not on others. So characters, all characters that have movement and have some type of collision detection are going to have a rigid body on them. So you guys have probably had a little exposure to this already, right? I know in PNP1 you guys use rigid bodies. So most of this should be review for you guys, but the mass, what does this control, right? What does this control? Max? How heavy the object feels, right? Definitely. And the drag, what the drag is, this is basically how much friction is going to be applied to the object when it's in free fall. So a good way to think about this, and this is right off of Unity's website, is that an object with very, very low drag, like something like 0.01 or very, very close to 0, that's like a very solid steel block or a big metal block, something very heavy, very dense, very hard to move. And something with a much higher drag, like a value of 10, that would be like feathers slowly falling down or leaves falling, something dynamic in the world but has very much drag falling to the ground, a balloon, something like that. So yeah, and we're going to test this stuff out. So kind of like air resistance? Exactly, yeah. So angular drag is applied to the same thing, but this is the same the same concept as drag, but in terms of torque and in terms of rotation. So if you have something on a hinge or you have something rotating around, the angular drag will affect how fast that moves, how much air resistance has it when it's rotating. So we'll get into more detail with these, but let's just test some of this stuff out. So we need a rigid body on these objects, and I'm going to go ahead and grab my character and not rotate him, since we've recently learned that, and just move him onto this platform to make it easier to test. I don't know what is going on with my Unity. Yeah. Something with the light.
So you put a rigid body on both of them, and the other one wouldn't fall.
Yeah, something's weird with my material. I didn't put a rigid body on the other one. Not yet, right? But you should be able to run into it and collide with it with the player, right? Because they have another rigid body. The character has a rigid body on him as well. Oh my God! Now it fixed it. That's some real weird visual bug. Yeah. So don't go to 5.3.5. So there you see, you can have these two cubes in here that we can interact, and because their mass is set to 1, they're very, very light, and I can kick them around. So the other thing we need to do to interact with these objects is change the tag. So we did a little bit of the usage of the tag, right, for entering a trigger volume, like checking if the tag is a player, allow them to, check for that if they're pressing E and, modifying their Boolean. Right, so we're using tags already, but we have made this custom tag in here called fizz, and this is what the grav null is looking for. So it's looking for an object with it. Once it collides with a certain object, it's checking for the tag. If it's fizz, then it's going to be picking up the object, and we can actually take a look at what's going on when the player is picking up that object. Let me not go to maximize so we can see some of this stuff. Project. All right, so now I'm able to pick up these objects. And let me move this stuff out of the way. All right, so watch what happens when I actually pick up the object, because you can see what is going on with the grav null. So all we're doing is modifying the drag of the object. So when you move it around, it stays in the volume. You can actually adjust this value. So you can't actually fling and lose the object while you're holding it down. That's because it's losing the connection. It's losing that connection to the volume itself. But all we're doing there is see how the use gravity is getting checked on and off. So as they pick up the object, we just turn off use gravity and adjust the angular, or adjust the drag, excuse me. So you're very easily able to make adjustments to this moving forward, and we'll show you where you can do so. So I made the tag one. I always do this too. So that's the thing that you want to do. So if something's not working with your object, it's probably the tag, because I forget it all the time myself. So the tag and the rigid body is how the objects will work. So let me go back in now, and so now if I pick up the level blocking mesh, notice how the center of shift. So notice how the center of the object, or the center of the grav null, where that sphere is right on the corner of the cube itself, right? And that's because that's where the pivot is. So this makes it a little bit difficult to do some movement with it, not impossible, but it just sometimes feels a little bit off, especially if you want to use the functionality of Q, E, Z, and X, so that will rotate your object. Q and E rotates it one way, and Z and X rotates it the other. It's a functionality that not everyone utilizes, and it's not the most easiest thing to implement, but it is possible to make some type of puzzle interaction with this, especially when you start to incorporate some constraints on the object itself. So that was the level blocking mesh, right, coming from the corner. Now I pick up a regular game object from Unity, and because it's in the center, the object feels much more natural in the center of my object. And now if I rotate, so let me set it down because that wasn't me rotating. What? Yeah, so now if I rotate, it's much more able to rotate on an easier, plane of axis. If you wanted to make some type of setup with this, we're rotating the objects into a certain position. So that's the two differences. So when you're prototyping with, boxes and things, or making certain setups, you probably want to be using level blocking meshes, or using the regular Unity game objects, or at least just be conscious where your pivots are. So you want to be able to manipulate these how you want, and it definitely is going to affect, how the object feels, especially when you start getting into more complex objects that are, when I mean complex as in not just a simple shape, that are, multiple different shapes. So the rigid body, so use gravity, right? This is something that you can turn off, and if I have these floating, I'm going to put them a little bit closer. it's going to be off until the player interacts with it, right? And now it's another way to do this. And so by default, use gravity is turned on, and you probably should leave it on for the most part. Another way to do this is we have a script in your project right here called rigid body sleep. Really simple. It's just one line. Basically, all it is just getting access to the rigid body component and putting it to sleep. So just show you that so you can see it. And this is definitely something. If you see a script in the project that either you're using or you're interested in, just open it up and just take a look at it and see what's going on. It makes it a lot easier to understand. So here you'll see this little line here, requires component of rigid body. Basically what this does is if you go to add the script to an object and it doesn't have a rigid body on there, it'll add one for you. So this is a nice little workaround to make sure that this has the right component on it. All right, so now with that, all we can do, so let me put it on both of them. So now they'll hang out there. This is really good for certain setups, like the Jenga tower that we have in the danger zone. When you have multiples that are stacked near each other, they might start to like wiggle or collide with each other, and you might get the right movement. Say you want this to happen at a certain time, you could have it basically, and it doesn't have to be just the player. It's basically if I throw something at it, if something collides with that, it's going to wake up. So you could have a trigger volume that enables that or turns it on or off. So something that you can utilize in your level for certain setups as well. All right, so then moving on to the rest of this. So is kinematic. What this is helpful for is mostly what you guys can utilize this for is animating rigid bodies. So you can have some type of platform, and I'm actually going to show off a spring joint this month that actually a student had done a few months ago, and it was a very good demonstration of using a spring joint. So say you have some type of a platform that has a rigid body. Turning on this is kinematic is going to allow you to apply animations to this and have an animator because the rigid body is basically driven on the physics system. So without this, with this component, you're relying on another system, altogether. And this is just enabling you to incorporate another system as well. So another thing this is used for, which everyone's probably seen in games, is when your player dies, like in a third-person shooter or something, they go into ragdoll mode, where the whole body just goes limp. That's basically using a rigid body, and it is kinematic because they're applying animations to the character, and then when they die, they're just letting the joints just take over, and physics just drive them to fall however they want to give that dynamic look. So that's a common usage of it in the industry, I know, on that like high level, but not of something we need to be focusing on. So interpolate, don't really mess with this at all. This isn't really useful for what we're doing, but you can definitely look into it on Unity's documentation because they have this all stuff right here. I referenced this right in the assignment itself. So it's basically just saying try one of these options if you're seeing jerkiness in your rigid body movement. So it's just something you can mess with, but they don't really tell you full detail what's going on, except right here they'll give you a little bit more information. So smooth base transform for the previous frame. Yeah, see, not a lot of information on a lot of that stuff, but the discrete, continuous, and continuous dynamic. This is stuff that you will definitely run into in the future. So by default, discrete is the collision detection that comes in, and basically all this is doing is detecting collision as it comes up. So basically, colliding with certain objects, Unity is calculating it differently. When a dynamic object or a rigid body is colliding with another rigid body, two dynamic objects, it's a lot different than when it's colliding with a static object. So discrete is going to keep all that in check. So continuous and continuous dynamic, if you take a look at their documentation, basically what this is for is when you have fast moving objects. So what's happening with the collision in Unity is every single frame an object is at a certain position, right? And every single time it's getting updated, it's in a new position. That's happening 60 times a second, right? Well, if an object is moving so fast, and say I want to throw like a ball at the wall or throw something at the wall, if I throw it so fast, at one frame, it's right in front of the wall, like right before impact, and then the very next frame, if it's moving so fast, it would be on the other side of the wall. So Unity just knows, okay, at this point it's on this side of the wall, at this point it's on this side. I'm not really sure how it got there because I'm already calculating it so many times in 1 second, but I just know these are the two positions. So that's what may happen when you throw something so fast that it just flies right through the wall in your level. So with continuous dynamic, what this is doing is it's gonna, or with continuous and continuous dynamic, what this is doing is it's checking how it's getting from this point to this point. It's actually calculating, is there anything in my way? If there is, prevent that from happening and, go to a new position. So that's what that's used for. So these do also see right here, this has a big impact on physics performance, so leave it set to discrete if you don't have issues with collision of fast objects. So I can't really say it much better than that right there. So leave everything as discrete by default. It should be, for the most part, good enough for what we're working with, but just know that this option is available. And you can use this to detect certain problems in your level as well. So dynamic, what dynamic is doing is this is for right here, also used with continuous collision detection against mesh colliders without a rigid body. So you should really be staying away from mesh colliders, and this will lead me into definitely a good point of we can do a lot with simple colliders, and we're going to see that in the next experiment. So really just stay away from mesh colliders altogether, especially in Unity. Certain game engines handle them differently. Like what Unity actually does is takes all of that geometry individually and actually will duplicate it and use that as the collision. And that's not the best way to actually make a mesh collider. I know Unreal, they use a really great system to basically, it's like if you were to have some type of strange object or like something poking out, they'll take, basically if you were to imagine the object being wrapped in cellophane or something, they basically just make this little shell around it, and that's the mesh collider. And those are a little bit more practical, but also very, very expensive. And then if you're having mesh colliders with dynamic collision detection on them, it becomes so much for it to process that your machine can't even handle it. So you really want to stay away from mesh colliders altogether. And you'll see in the next experiment that you can really do a lot with just a few simple colliders. And then constraints. These are probably you have experience with these ones, right? Cool. So this will definitely be a review for you guys. But these will definitely allow you to, think about now that you know about constraints. Think about how you can now apply those to the grav null, right? So if I want to have a crate or something on the ground here, and I want to, let's freeze the rotation, and let's say it only slides in the z-axis, right? Now let's say this is going to be like an elevator that the player can move up and down, right? So this one I can only slide on the ground, right? Now this one you can move up and down, and you could actually and this is where the is kinematic could come in, and you can actually stop it. You can animate this to get to a certain position, or you could also like have a trigger volume that showcases when this object gets in the volume, destroy it and instantiate a static version of the same thing, right? Just all smoke and mirrors. No, because I turned off the rotation. But you're saying with the buttons? Yeah, you can't rotate it with the buttons. So you can limit it to only be, like say we want to do it, like, let's see, we probably want to rotate in the Y. So now I should be able to rotate one, but I can't rotate the other. I can use Q and E, but I can't use the other. So this is much more useful for like, rotating like a plank or something long or a little bit odd in shape. That way you can get a much cleaner rotation without it wobbling and doing certain things. So, this is really I'm showing you guys the tools, and now from here you're able to create cool little interesting setups in the level itself, just using the gravinol. And one thing to keep a note in here is we're not going to be doing any scripting. So if scripting isn't like your strong point and you feel like you want to design in other ways, this is a really good way to do that. And a lot of the stuff we're going over, you can accomplish really cool, creative, interesting designs without having to do too much in scripting. Yes, it's going to make your stuff a lot better, and you'll be able to have much more control, but not required to create interesting setups for the player to experience. All right, so yeah, that's basically the rigid body in a nutshell. So next, what we're going to talk about is the physics materials. So on your objects, right, every object in your scene will have a material down here, right, and you'll notice this says a shader. So this is what's actually being rendered. So here in the mesh renderer, actually this is where you can also plug in the materials. So you may also see sometimes objects will have multiple sizes, and that can be an artist, or you can set up in Maya, these faces have this material, these faces have this material. That's why you could have like a van or something have like a rusty, very dull looking body, but then have like shiny or like glass looking material to the window, and it all be one object. So you can actually assign multiple materials. But this is what's being rendered to the screen, right? What's being displayed. Now here in the box collider, this is the slot right here for the physics material itself. So I'm going to go ahead and just see. This is my my Unity 3D object. So I'm going to delete my level blocking mesh. I'm just going to duplicate this guy a few times. All right, so I'm going to call this one rubber block. This is ice block. And let's call this one stone. Okay. So if we have included, the reason I called those certain names is we've included some for you in this project. So if I'm on my ice block. If you go ahead and just hit the little circle here next to the text box, this window will come up, right? And this is just searching the assets of your scene. You'll notice that we have a few in here already. So ice, rubber, and stone. So I'm going to go ahead and just assign the ice material to the ice block. All right, and I'm just going to take a look at it. So you notice these three properties here. So dynamic friction, static friction, and bounciness. So these are pretty self-explanatory in terms of what these are doing. So it's that dynamic and static, these are referring to the types of object in the Unity scene, right? So static objects, Unity doesn't have to calculate every single frame. They know where they are, it's not changing. And one way to help alleviate some of that is if you look at any object in the inspector, you're going to notice this little checkbox here, right? So once you go through your level, you're going to start to organize this. This will be in level design, but if you start to understand this now, you can preemptively start to organize this and make sure everything is clearly labeled in your scene. What objects are what in their logical order. So checking this on is one, helping out with the lighting. So Unity can calculate these objects as static and help bake the lighting to certain static objects. So that's important, as well as help it just understanding which objects are going to be dynamic and which ones have rigid bodies. So basically all your level blocking meshes or all these static objects in the world should be checked on with this. So that friction, friction is referring to when it's going to collide with those static objects, what it's going to behave like. And dynamic is when it collides with other dynamic objects, what is it going to behave like. And bounciness is, self-explanatory. When it hits an object, how much force is going to be applied to it and how much is it going to react and bounce. So you'll see with the ice, with these values very, very low means that it's not going to have any friction at all. The closer to 0 means it's no friction, and closer to infinity, or I like to think of it as 1, because at past 1 you really won't see much of a change. It is, but really 0 to 1 is a good scale to think of, because look at this is set to 0.001. Like that's really, really low, and that's all the way to the the thousands of decimal places. So start to mess with these and adjust them. So you can copy, just duplicate these, like duplicate make a copy of the ice and then mess with it, or just, name it something different. So I'm going to go ahead and put the other materials on here as well. Rubber and stone. So you can take a look at the other ones. Stone's not very interesting at all, just high friction, so it's going to stop really quickly once it collides with an object, and then the bounciness, it's not going to bounce at all. And then the rubber, you'll see it has a high friction, but also a very high bounciness. So this is going to bounce. So this is good for tires, or traffic cones. If you want to actually adjust it, maybe your tires are pretty bouncy, but other objects just bounce a little bit. You adjust this to like 0.5, 0.4. Definitely just mess with this stuff. This is these are experiments to start to play with some of this stuff and prototype it. Maybe like bring in an asset from the Unity, either the Unity store or our asset depot, like a trash can or something, and try and make it feel like a trash can would. Have some density, have some weight to it. Question?
If I were to use like the ice block, but use it as building material, so for the hockey rink, is that possible? So
yeah, so definitely. So one thing to note about the ice is that it needs another ice surface to slide on. So what I'm actually going to do is this platform here, I'm going to apply a physics material to it. I'm going to put ice on it. You can make a little piece of geometry off to the side if you want to make a little rink, if you don't make it a whole thing, but you can do that as well. So now let's go ahead and test some of this. And one thing that's important to note too is to make these actually feel how we want to, we're going to need to adjust the mass values to make these feel like the object they should, because right now they're all cubes. So in the experiment, I have some values. Those were just values that I had messed around with and felt that they were accurate, but they were definitely not the only correct answers, right? Everything can be adjusted based on what the object is and how you want it to react. So for my stone block, I don't know, let's just try. I'm not even going to look at what the values are. I'm just going to try 15. Let's see, for ice, let's try 8. And then for the rubber, this would probably be a little bit lighter. Let's try 5. So see, this is my, which one is this? They all look the same. Yeah, this is the stone, you're right. So this one, as soon as you throw it, as soon as it hits the ground, you'll see it just kind of comes to a stop there. Doesn't really react much. It's kind of a grump. But it's heavier now because we adjusted the mass. So it takes a little bit more effort to pick up and move. All right, and then you can see the rubber block. Oh, there's the ice one sliding away. Let's go get it. So this one you'll see. Go ahead. Yes, the floor has ice on it right now. So I can take the ice block and right click and slide, and you'll see it's just going to slide. And it'll pretty much just keep going and going forever. So you can adjust the actual friction value. Oh, no, couldn't get it. So you can adjust the value of it. Oh, there's the constant damage killed it. So yeah, feel free to make duplicates of these. And there's the rubber block or rubber material, and you'll see how it's behaving much differently, bouncing around. So definitely applicable to certain objects in your scene or in your level. And hopefully some of this stuff can inspire you to how you can create even more setups from here.
Would it be possible to like add a bottom layer to your character's shoe and like a trigger on there somewhere to where if he hit the ice, it would make him slippery as well?
Yeah, that's something you can play with. And remember, as long as you can keep it like a temporary thing to where it's contained to your area. Yeah, sure. I mean, it's definitely something to play around with. Also, I'll show you guys this now, but definitely remember for going into level design, you should keep this pretty neutral, but I like to show you this now because you guys should be able to experiment with some of the gravinol itself. So if you go into the character container, right, so this is what holds the character in all of its fun functionality, this gravinol system in here, if you open up to the pivot into not a camera, into gravity gun, in this gravity gun script, you're going to see a lot of properties. So ideally, you guys are going to do all this stuff when you get to all these finalized values are going to come into play into DES 3. But it's good to start to understand what's going on here because you can adjust some of these values. So the push force, this is basically when you throw an object, how much force is going to be applied to it. Right? So the grab force is how much force you need to actually pick up the object. So you can actually set, if based on this and what the mass is, this is what's going to cause some objects to be able to be picked up and some not. So basically, anything with a mass larger than 50, the gravinol is really going to have a hard time picking it up. And that's how you could either adjust that or design around that value. So definitely the instructor that wrote this is a really very good scripter and put in a lot of these little tool tips here. So you can hover over it and you'll see exactly what's going on for each one of these. So this is where the gravinol is located. And again, for this assignment or for these experiments, when you're doing some testing or working on some, maybe you want to prototype one of your own setups in here using some physics, feel free to adjust some of these values and actually see what's happening. We do have this really cool functionality I'm going to show you guys about, but never really utilized, this only one item. So if you turn this off, you can actually pick up a bunch of items at once. It makes some like puzzles and stacking objects a little bit difficult, so pick up multiple. But maybe you have like an upgrade or something in your level where you could pick up multiple pieces. It's really cool when you like pick up a whole bunch of like trash or something, like spray it everywhere. But again, this will start to change what the design looks like. But again, something to mess around with. And then down here, this is when you see the objects actually changing color. That's this value here if you want to toggle that on or off. And the other thing I wanted to point out real quick while I'm in the character is right now the rigid body of the character is really low. It's 1. So that is something when you notice the character on a slope or a slant and he starts to slide, that's because he's only have a mass of 1. So you can also adjust that if you'd like, as well as these two values, airspeed and air control. So right now when the player jumps, you'll probably notice if you try to make any type of platform, so I'm kind of going on a tangent right now, but we have some time, and this is good stuff to get prepared for level design. When the player jumps right now, especially from standing still, so if I jump and try and move forward, and we can use the grid on the ground as a good test, if I like jump and then push W, I can only really move like 1 square. So it's really hard to make like timing jumping puzzles. If I'm running and then jump, I'm good, but it's that airspeed right here that needs to be adjusted. So Mr. Gazaway was messing with this, and we just didn't get it into this month's project template, but it's now updated. So the airspeed was 9, and the air control I think is 6. I think that's what we went with. And again, this is just something we tested and he felt right. This could be played with more, and then something that you guys can agree on as a team in level design. So now it's more of it could be even a little bit more. Sorry, you can agree on in DES 3. So this is about 4 units, looks like, which is a little bit better. You could adjust it even further, but definitely how it is right now is a little bit tough. So if you're noticing yourself like you're actually having these platforms like, wow, this is really hard to achieve, it's probably because your values are, this air control is 2. And the airspeed, what was it, 6? Yeah. So you can tell just the value change there from 6 to 9, really big difference. So 6 and 2 is what you guys are set at right now.
Is there any way to increase the strafe speed?
The strafe speed?
Like using like A and B. Really slow.
Yeah, I think it might be the move speed. But like this, feel free for like this month to play with a lot of this stuff, because when you guys go into level design, you're going to get a fresh project. So you'll have all of these updated values, but this is the month to, do some testing and adjustments to see what happens. I think it would be this. Let's put it up to like 5. Oh yeah. That's how you get your straight faster. I'm not sure. I haven't built this character. That was mostly the instructor, the level design instructor. So you can pick his brain about it. I know he'll probably give you the initial answer of why are you changing the character. But it's okay to at least understand what's going on behind the curtain. You don't. Yeah, I mean, that you're actually going to learn all that, basically how to set up WASDA controls. You learn that in PGF2. So that'll be a few months for you guys. All right, so back on track. So we got our physics materials, pretty self-explanatory. So now you can definitely go in here and start to adjust the masses of some of these. But let me make one other point I need to make to make sure everyone understands this. I'm going to duplicate the stone block. And now, so you'll see these has the same thing, has a mass of 15. But I'm going to just scale this up. Let's give this a value of 3. Yeah, so right, both of these have a value of 15, right? So you would think, right, that these would have the same properties, right? They'd be about the same weight, but that's not the case. So if we wanted to make these feel like the same material, notice that if this was made of the same material, the player would not be able to pick this up over their head, right? This would be much heavier, and this feels almost like a lighter block because it's much larger. So the point I'm trying to make is that the volume and the size of the object is directly proportionate to what the mass needs to be. Anybody remember that magical triangle of, what is it, m over dv? Yeah, like mass is density times volume, or density is mass divided by volume. There's a triangle to where it's basically a formula to find the missing one. So the mass needs to be adjusted to compensate for the larger volume to make it feel denser. So this would be, probably. And you could try, like, I would recommend, you could say, like, well, this is 3 times larger, let's try 45. You could try that. Let's see what it looks like. It's always a good place to start. Yeah, it feels a little bit better. Maybe you could go even higher. Yeah, it's still, you can actually change it right in here to test. Yeah, maybe even more. But it's definitely starting to feel much better. All right, so that is physics materials and the rigid body. And yeah, just making sure that your objects are the proper scale to the mass is definitely important, and you'll notice it too when you go from area to area. So start to make some prefabs and things like that if you want to build some things and actually have some set values. That way, when you go into building this as a team, everyone can have these set prefabs and everyone can agree on certain values, because you'll go from one area to the next, and one area will have crates that feel good and have a good weight to them. And then later on, either those same crates are non-interactable, or those same crates are much lighter with different values. So start to feel this stuff out and test some things, and bring in some actual assets and make them have a good weight to them that you want to be actually interactable in your level. So another point I'll mention, because it's important that you guys know this, and this was actually a piece of feedback we got from the DES 3 students about wanting to understand layers more. So we've talked about tags, right, and how tags work, and you can utilize them to gain access to certain objects by tag or interact by tag. So layers, what these do is basically allow interaction on certain levels or not. So if you go to Edit, Project Settings, and it's in Physics, you'll see this is a layer matrix, right? And this is the one that we have set up for our project. So basically what's going on here is wherever these checkboxes are on, that means these layers can interact with each other. So right now, everything in the default layer can interact with everything else except for pickups. Another thing too you'll notice in here is the sentry gun can't interact with the sentry gun. The reason why is because the sentry gun has a laser that's scanning across back and forth, and if you had this checked on and you had two near each other and their lasers ever crossed, you get basically a huge frame rate spike and just unplayable to a point. So basically what this is doing is ignoring those. When they cross, they don't even realize the other person is there.
What if the laser was on a different plane? Like if it was right underneath that?
That would be okay, but usually like the turrets are like the same height. So if it's on a flat ground, usually they're there. And same thing for like the pickups. Having the pickups not interact with pickups means that you could have two pickups near each other, right? Because if their volumes were set to each other and they're checked on, they would basically just collect the items right away. Same thing with water and pickups. You can have pickups underneath the water volume, things like that. So this is pretty cool stuff. If you're doing anything with like a force field or any type of volume that like the Jude, the one student in Des 3, he really utilized these a lot because he had certain, basically, some of you have seen his level, I'm sure, where he has blue spheres and blue force fields and green spheres, and like the green ones can go through certain ones and others can't go through others. He's using layers to allow, basically not allow the player to go through the force field, but allow these spheres to go through. And that was, this is the matrix and how you can use it. And you'll see if you open up like a brand new Unity project, theirs isn't as complex as ours. Like, the bullets, the sentry gun, the pickups, the setup volume, the map icon, and the projection, those were all stuff we added. So by default, it's basically just like default transparent water and UI, maybe the player as well. So you can definitely add more layers to this. And the same way you can add tags, that would be done in tags and layers here. So this is where you can actually add your own and start to interact with them. So a little piece of extra information, not directly relevant to the rigid bodies, but definitely important to understand for building your level. All right, so that is the end of the first experiment. So I'm just going to go to Perforce quick. And go to my project. And now all I did so far, I just worked on the scene. Oh, I did move the character too, so I'm just going to update my rigid bodies scene. So let's do it from the IND folder. So I'm just going to reconcile to get the changes in there, but after that I'm going to check out my files. So definitely want to make sure you guys understand the concept of still checking out some things. I had some Des 3 students come up to me and say, I just realized now I can check out files and work on them. I was like, I'm sorry I failed you. You should have known that months ago. So you don't have to always reconcile offline work. And it's a good habit to get into to understand checking out files, because this reconciling is more of a unique feature to Perforce/Unity integration, getting the two to work with each other, and not sure why this is taking so long.
So when you check something out, and then when you bring it back in, it's like already, it doesn't have to load anything?
Yeah, so if I can cancel this. This is why you definitely shouldn't reconcile right here. So when you check out a file, what's happening to that file is it's going into your change list. So by default, all these files are read-only. We shouldn't be changing any of them. But reconciling is going to add them into our changes and check them out for us after the fact. So another way to do this, I should be able to drag and drop this right into my hub there, and that'll check it out for me. Oh, that was the hub. Let me make sure I get the rigid body scene. That'll check it out for me. And then submit. All right. So yeah, now I'm just going to be working on the scene for right now. So I'm just going to check out the scene and the meta file. So see, yeah, when I check out the file, see that now it's in my change list. So now this is technically editable or marked for edit, no longer read-only. So for this experiment, we're going to be going over adding complex collision to a game object, right? So by default, when you create basic Unity objects or the level blocking meshes, they come in with collision for you, all ready to go. But by default, when you get FBXs or objects off of the depot, they're not going to have collision on them. So we're going to take a look at putting collision on an object like this right here, a little bit unique, not just the box collider. And I'll show you two different ways to do so. So we're going to need an asset from our asset depot. This is the pallet jack. If you don't already have the assets, you can get just that asset, which is in the business folder. So I'm going to import package, custom package, business, pallet jack right here. This little window comes up. It's in the business folder, and then pallet jack 01. And then you'll see here we have a material, a texture, and a FBX. So we import that. It's going to go into your art assets folder. And if you didn't have one, it's going to create an art assets folder. And inside there, your business. All right, so here's our mesh right here. So I'm just going to go ahead and, man, that looks real funky. So I'm going to drop two of these in here. Actually, no, let's do one for right now, because then we can duplicate it later. So there's our mesh. What's up?
For the importing,
Sure, it goes to the rigid bodies.
the business folder, do I just do all of them, or just?
You should be able to you can only import one package at a time.
So just do what was it, pallet jack?
Yeah. All right, so there's our object in the scene. So now you'll notice if you look at the mesh itself, right? So we have the mesh here. This is the mesh filter, what's being displayed. Here's the renderer, which shows basically how it can cast shadows, the material. And we don't need an animator. Not sure why that's not on there. Let's get rid of that. All right, so now if we go ahead and play, one thing you'll notice that's not on there is a collider. So as a player, we can just run right through this, and you know that's not what we want. We want there to be collision on this object. So first thing we can do is add box collider. All right, so by default, you'll see what Unity is doing. It just takes the object, it notices its largest point, so basically its tallest point and its widest point, and it's just going to encompass that in a box. So we're done, right? It's got collision. We good? Wait, I know I can get on top of it. Ugh. Yeah, so this isn't acceptable, right? We should be able to walk over. It doesn't need to be completely exact, but we want it to be much more indicative of this object than what is being displayed right now. Much rather work like that. All right, so there's two ways to do this. Unity showcases on their website one way, and this is one way that's definitely acceptable. Both of them are very, very much acceptable ways to do this. It's really about what you want to be doing with your object. So what Unity is showing is having multiple child objects that they all contain a box collider, right? But another way to do this is we can just start to add multiple box colliders to one object. So say for our first one here, we want to go ahead and just edit this, right? So when you hit the edit collider, these little faces come up. Go ahead and move these guys into place. So say I'm just going to put this first one around the base here. All right, I got the first one around the base there. And now I can go ahead and just start to add another box collider. So you'll see another one can come in. I can edit this one. I'm going to put this one around the two little feet down here. So one thing that this is useful for is if this object is just going to stay as is and not be adjusted or changed like dynamically throughout the level, then this would be the way to go, right? But one thing that I don't like about this, and this is just a feature of Unity, is that you can't rename these. So you're just looking at these and it just says box collider over and over again. And you just have to understand the order you put them in or be able to just select them and get the one you want, right? So what? Yeah, you could make a third, or you could make a fourth that goes around this handle here, but just for the sake of time, I'm only going to do 3 right now. But so this is really efficient because this is just one game object, right? One game object with multiple colliders. So I'm going to go ahead and test this out. And that feels much better. A little bit, maybe I could adjust that a little bit more, but you can see that this thing actually has collision on it. I can stand on the handle. Pro. Nice. But definitely has just a little step up here, and this is nice that the player doesn't actually have to jump to get over this. It's just a little step up, and then they can keep going. So this is definitely along the lines of what you want to be working towards. And this is nice because this is just one object, right? So this is just a static pallet jack in the world. Cool. This is what we want. Good to go, right? But say we want to have a little bit more control, and we can do it the way that Unity is showing us to do it. So what they want, or what they suggest as a way to showcase it, and this is definitely thinking more of being able to manipulate this or script certain events to happen with this object. So if I go ahead and duplicate this one, just going to rename this. All right, so I'm going to remove the other 2 colliders. So we just have this base one here. All right. And now what I'm going to do is I'm going to right-click on this object and create an empty. Let's call this collider 01. And now from here, what I'm going to do is I'm going to add a box collider to this object. And I'll go ahead and edit this how I was the others. So this is helpful, and you'll see in the Unity documentation they have the picture of like the assault rifle, and it has like a scope and a noob tube and like a stock, certain things like that. So this is cool because say you want to actually destroy or animate or move one of these or one of these colliders, and maybe even part of the mesh as well, you can do so because this collider is on its own game object, right? I can actually move this game object around, and the collider is going to move with it. So you could, enable this, turn it on or off. For some reason, you could actually manipulate this in some way without affecting the one above it. This could also be good for like maybe part of the handle is missing, and the player needs to actually go find the handle and attach it. But then, when you attach it, you turn on this collision volume. Question? What did I do to it? I was basically recreating this other one over here, but in another fashion. So yeah, I just moved the second one over the feet. Now I'm just going to create another one. Call this Collider 02. Add another box collider. You can actually just take the game object. You don't want to scale it. You don't want to scale the game object, but you can just move it and then edit it. It can be a little workaround.
Is that where the grab node would pick it up?
You are on point today, man. You're way ahead of me. So what do you think? Yeah. Well, no, right now the Gravenol can't pick it up at all. Yeah, so but right now, these are about the same. Two different ways to set up collision, but they're pretty much the same. But that's a really good point that you bring up about the Gravenol. So this one, it depends which object I put my rigid body on, and which one I tag as fizz. So if I just take this pallet jack 01 and add a rigid body to this, and then tag this guy as fizz. Now if I go to my other one over here and do the same thing, I'm going to tag this as fizz, and let's add rigid body. Right now my mass is default of 1, so they're going to be real light. So you'll notice with this one, no matter where I pick it up, if I just try and just pick it up right at the feet, at the base, or like right at the handle, no matter where I pick it up, it's going to recognize the object is there, and it's going to go to that middle point. So now this one over here, you'll notice I can't quite pick it up until I get to this point right there. So maybe you want to have your base around like the handle or a certain point that the player needs to actually manipulate this point to actually get the object to behave the way they want that they want it to. So again, this other one down here has multiple different colliders as children game objects. So you have access to those if you want to manipulate them or control them in some other way. So there's two ways to do the same thing. It really depends on what you're doing with that object that's going to affect which route you go down. So this one is a bit more efficient because it's just one game object in the world. But remember, multiple box colliders. And if you want to like script, get component box collider, it's just going to find the first one it finds, and it's not going to recognize the others. So yeah, good useful stuff there. And you could tie this back into what I showed you with the van, where maybe this handle, you attach this, and then this is the interact point. So I could take this guy here, and let's go ahead and freeze this so it can't rotate it, and you can't move it in the Y and the X. You can only move it in the Z. So maybe this has like a stack of crates on it in your level, and get the one out of there. Come back. Oh, it's constrained. Perfect. So, maybe this has some crates on it or something, and, the player can slide this and move it out of the way. And it's real light right now because, the mass is 1.
Can you stand on it?
Let's try it. Oh. Let me,
Kind of just like fling it and jump on it and fly away. Can you sport?
no. As soon as I let go of yeah, if I keep holding W, I'll like go. Yeah, you'll learn that in level design when you have moving platforms. When the player enters a platform, the player becomes the child of that object.
I did that for my design 1 class. This is a lot harder than I thought. Getting something to move and the character stays on it.
Yeah, it's tough. It's harder than you'd think for sure. So there's two examples of objects with complex collision on them. So you'll notice that wasn't just add a collider, done, right? We actually had to move some around. And if it looked like that was easy for me, I've been doing this for quite a while in multiple different engines, adding collision. So it takes practice. So find some random objects in your project or in the asset depot that you may want to use in your level eventually, and just start adding collision to them, right? And don't have to do it multiple times. Now that I have collision on those, I'm going to go ahead and let's rename this one. Let's just do this one pallet jack. Let's call this pallet jack 0, since the other one's 0, 1. All right, so let's just take these, and I'm going to drop them in my project. So I have two different ones, right? Two different setups of the same thing, and it's the prefab. Go ahead and save my scene. So coming back to Perforce, what did we work on, right? So I have my my scene already checked out, which has my two new pallet jacks, but we also added the pallet jack folder itself. So if we go into my project, into the assets, and what was that? Art assets, business. There's the meta file, so let's go ahead and add that. And I'm going to use the drag and drop functionality just to show you guys that it's all the same. Oh, and one problem, I'm going to fix this right after this, so anyone that hasn't followed along, you can change this, or you shouldn't have to change this. But see this material number 54 right here? So if I go and try and submit this, we're going to get some error saying that Perforce doesn't like these wildcards. So it's number sign, exclamation point, @ sign, basically anything shift, any of the numbers, it doesn't like those symbols. So I'm just going to go back into Unity and change the name of that. And that's just a mistake because we have that in there. That's the name of the object, the name of the material in the package itself. So when we imported it, it just imported this material. So I'll re-export that. And if you guys see any more of these throughout like the next few months, let us know so we can fix those. Yeah, the number sign is the problem. And that's just something like on TurboSquid, or I think at the asset store. Just by default, when certain programs create materials, they include that number sign, and it causes some issues in other programs, obviously, like they're not thinking about Perforce. So there you see that the material changed as well as the meta. I didn't need to change the name of the meta file; it just changed on its own. So let's go ahead and just take this whole pallet jack folder, and I'm just going to drag it, drop it in there. So you see, adding all the new files, and then we also have these my scene checked out. So let's go ahead and submit that. All right, so now I have my, all these changes are on the depot. And again, I know I probably sound like a broken record, but take the time this month and these last few days to make sure you understand submitting work to Perforce, because it's only going to get more difficult when you get into level design as well as Des 3. Question?
Yeah, can you go back a little bit what was the first thing you did in this part?
In Perforce?
Yeah.
So did you already have your scene checked out?
Yeah, sure. Yeah.
So I've been using the drag and drop functionality. So if you go and find the objects, the scenes you want to work on, or the scene that you have been changed. So here's the rigid bodies. I'm also going to grab the meta file. You can just click and drag. If you drag right into the change list you want, it's going to add those files, and you'll notice it's going to check them out by the symbol. You can notice what it's doing. If it's a new file, that's what I did next. I grabbed all my pallet jack files and dragged them in, and that's marking them for add. Okay, cool. And then you submit from there. So again, I'm going to be working on the rigid body scene, so I'm going to go ahead and check that out. So while I'm working on that. So in the third experiment, we're going to be going over a little bit more with the rigid body as well as hinge joints, and then we're also going to do a small little demonstration of spring joints. So this isn't in the experiment itself, but it will be recorded if you want to review it, and it's definitely good information. Marcus asks, can you add a rigid body to empty game objects to have multiple grab points? He's online, yeah. Wait, what? Adding multiple grab points is tough to do because the grab null is going to be detecting one of them at a time, but test it out. Add multiple and experiment with it and see what you can do. You can have a rigid body on an empty, and that can control the object, but having multiple grab points, that's something you're going to have to test on your own and see what you can accomplish. So we've got our scene here. So let me open up the experiment. So with this one, we have a few demonstrations of how to use hinge joints in your level in different ways, as well as just explaining them. So let me open up that. So here, this is just a shot of what we're going to be working on. This was done in the danger zone, but again, you can do this right in the scene we've been working on. So this is the first little setup I'm going to make, just a small little contraption right here. And the reason I have this color-coded is not because that's a nice way to texture it. It looks awful. It was just for a teaching demonstration to showcase which assets are doing what and which objects are doing certain things. So the ones that were blue, those are the ones with the rigid body on them. So the first thing I'm going to make is I'm going to just make the base. So I'm going to make a level blocking mesh. Create a cube. All right, let's see. This guy's got a scale of 3 in the X, 1 in the Y, and what, 5 in the Z. All right, and then the next thing we're going to need, and then I also have in here a mention of the snap settings, just as a reminder. This is an important thing to understand, and you will see this later. That is a hint that it's on the test. So make sure you know where the snap settings are, as well as remember hold control to snap objects in place. So really useful, and that's an amateur mistake we see all the time. It's so evident when people aren't using snap. It just looks so sloppy, and it's a lot of work to clean up later. So just get in the habit of using it, and then also get in the habit of changing these controls. Like if you don't want things snapping to 1, try 0.5. Try an incremental value so you get something that feels right. So then if you ever get anything off value like that, like you have 29.71 or some value you don't want, you've been moving it around, you're like, oh shoot, I wasn't snapping. You can hit snap all axes and it'll reset it for you. All right, so there's our little base. Next thing we're going to make is a little sliding board that's actually going to slide. So for this example, I'm just going to be using a level blocking mesh because the pivot isn't too crucial because we're constraining it. So I'm just going to duplicate the base and just rename it sliding board. Okay. Let's see, this is 1.1 and 5, I think. Yep, and 5. All right, so there's the board itself. I'm going to move it into the middle, move it up 1. So the reason I have the frame around it, what's important for this example is the stopper itself. So make sure your two pieces of geometry aren't inside each other as well, because if they're clipping just a little bit, you might get a little wiggle and hiccup. Because this is physics, remember. We don't have complete control. We have to do the best we can to communicate to the system what's going to happen and be in control as much as we can. That's why the constraints are very crucial. So the little stopper on the back is important so it can't slide off the edge. So I'm just going to make that one. Let's call this stopper 1.5. Yeah. Really, I'm just making a quick level blocking mesh and then just typing in the scale that I have in here. So these are, again, just values I found, but this isn't anything that's set in stone. These are just making a little prototype of a setup. This could eventually be like some type of rock or debris face, and this could be like a plank. And then like we could be climbing on top of onto a file cabinet. Like this could be an office setting, or really anything. We're just prototyping the setup itself. So this little stopper here, this is going to prevent our board from sliding. And the reason I have two little trim pieces along the edge in the image is just to showcase, to communicate to a player why you couldn't slide it the other direction, right? Well, if I can slide it in the Z, why can't I slide it in the X? So I just included that there for communication's sake, but I'm not going to build those right now. So with our sliding board, let's go ahead and add a rigid body to this. And let's not make it a mass of 1 because that'll fling around like crazy. Let's give it a value of 5. And we're going to need a fizz tag on this guy. And now we're also going to need a little pedestal to jump up to. So I'm going to duplicate my platform base. Move this guy over here, call this platform base 2. Alright, I think this is 2, 3, 2, so 2 in the X, 3 in the Y, and 2 in the Z. Real quick, I'm going to change my snap settings to, I'm going to go to 0.5 so I can just because I want to get it lined up in the middle like that. Alright, and let's give ourselves a little reward to get. So I'm going to grab a panel pickup, this little prefab right here. I'm just going to put it on top of my pedestal there. Alright, so I have some of my blocks over here. We're going to need those, so make sure you have a block nearby. Okay, so our board has a box collider on it. Or sorry, it has a rigid body and it has the fizz tag. The other thing we need to make sure is that we can only slide it in the z-axis, right? So we want to freeze the x and the y. Question?
What was the properties for the rigid body on the sliding board?
I just changed the mass to 5. And then same thing here. For the additional properties, we're going to freeze it in the x and the y so it only slides in the z-axis. And also we're going to lock the rotation so the player can't rotate it at all. Alright, now we're going to go ahead and hit play. So you'll notice, and this wasn't by just random guess, this was by a design that I had planned out, was that I made this 3 units high because the player can't reach up here and jump, right? They actually need to perform this action. So this is important to start to think about because you don't want to make a collectible that the player has to avoid this setup. And actually what I'm going to do is I'm going to move this out of the way. I put them too close together. They should be 4 units apart. So again, use the grid. Move the pickup. So that way that actually there's no way to solve this without completing this setup. So now this is about a multi-step process to completing this. So you can go ahead and slide the board back and forth, slide it into place, and now you'll notice here you're still a little bit short from getting up there. So now you can use the box. Oh, that's super heavy. So again, this isn't, not perfect. Let's go back and actually adjust that. Move a little closer. So, and it's important to understand, it's like, oh, well, it wasn't great, but I eventually got it up there and fixed it. No, like tweak these numbers and adjust it to make it feel correct, right? You don't want the player to struggle so much. It should be a lot easier for them to get up there. Right, so the first time I showed Mr. Gasway this when I was building this, he goes, man, if I saw that in every level, it'd be like an A+, right? Like the amount of interactivity there was much better than just an object hanging out on the desk or just sitting on the floor, right? I moved the board in place. I used the object to break forward. You could even do something to where, some of those cubes were blocking the board, so you need to move them out of the way to slide the board, and then you use that same object to stack and get up there, right? Like a lot of complexity, and again, no scripting involved, nothing too complex. How long did it take me to make that? Like 10 minutes? And so it's definitely a lot available to you with just some of these little setups and using constraints and using the rigid bodies. So any questions so far? No? Cool. So the next thing we're going to show off is a hinge joint. So this is useful in a lot of ways, and if anyone made a traditional entryway or wants an entryway in their level to some kind, if you don't want it to be walk up and press E, you can make it to where it's on a hinge. You can actually use the grab null to fling the doors open and closed. So that's one application for it. Here I'm just going to show off another way to make a small, minor little setup to maybe add some more interest and interactivity to your collectibles throughout your level. So I'm going to go ahead and take one of these platform bases. And actually, before I go too far, because look, I made a big mistake, and I have a bunch of my assets in the hub, which isn't a big deal. I'm just going to go ahead and clean that up before I move on. So definitely pay attention to that stuff. I'm going to go ahead and take all these objects. So I have my platform base, platform base 2, the stopper, the sliding board, and I'm also going to grab that collectible that I put with the setup, right? Because that's important. That's part of it. I'm going to grab all of those and drag them into the rigid body scene. And now the next thing I'm going to do is I'm actually just going to create an empty game object. And I'm just going to drop all of those inside of that. So I'm just making another prefab. So now, if you want, what did I do? Oh no, I made I made a game object inside of every object. So don't do that. So I had multiple selected and I hit create empty. So what I needed to do is just find the one I want, like platform base, create empty, pull that guy out. Make sure it has a clean scale of your empty game object. Don't have any scale value on it or else it'll make your textures look all funky. Drag all of those inside my empty and I'm just going to say sliding board setup. Right? So now I have this, and this time I'm going to hit enter. So now I can go into my assets and let's say I want to, where do I want to put this? Let's just make a folder. Let's call it prefabs or setup prefabs. Alright, I'm just going to drag my new setup in here into this folder, right? So now I can start to drop this, like say you want to have this in a few different areas of your level, you can just drag and drop this in here. And yes, these objects are going to be in like this. This is just a symptom of the level blocking mesh. All is not lost. You can just select them all, level blocking mesh, refresh, and now back. Alright, so and then from there maybe you want to adjust these and make them a little bit different from each other, but now you have a starting point to have this in a few different spots in your level, right? Like quickly make some prefabs of some of these setups. Maybe you have this built and then later on in your teammates area you have an opportunity to incorporate some of your mechanics as well. So that being said, let's delete the duplicate. Alright, and now let's go ahead and make another little platform base. So let's make a cube. Make sure this is the active one. Alright, let's call this beam base. Okay, let's give this 1, 3 in the Y, 2 in the Z. Let's move this guy back. Alright, now we're going to need another level blocking mesh. This one's going to be our long beam that's going to have the hinge on it. So this one we're going to give a value of 7 in the 7 in the X and 0.5 in the Y and 1.5 in the Z. Alright, now I'm just going to position this near where I want it to hinge from. Right, because I want this to hinge from a certain location. Alright, so I'm just going to call this one hinge beam. Alright, now let's go ahead and give this guy a rigid body. Let's make this a little bit heavier. Let's give it a value of 3, 4. Why not? And then we're also going to add an actual hinge joint to this. Alright, so here is the hinge joint component. A lot of stuff going on here. First thing you'll notice is this connected body. So this is useful if you want to have a series of hinges all attached to each other. So a rope or a chain or something with multiple hinges in it. And again, this is something that's going to be really good at swinging in one dimension, like basically in one axis. So you could have commonly I've seen students do like a chandelier or some big object that they like swing and break through a wall. That could be used on a few hinges, and then the last object is used with the gravinol. So basically, think about it as your parent-child relationship, right? So whatever the connected body is, that one is controlling the child, or it's controlling the object that's the hinge. So if I make this base here my connected body, wherever this object goes, this is going to be attached behind it, but it's going to be attached on a hinge. So you don't need a connected body in this setup for it to work, but it's just there if you want to have more control of it. And we'll show you two scenarios. This one you don't need it, and then after this I'll show you a setup with the spring joint where it's required, where you do need it for what we want to accomplish. So you can go ahead and drop in the connected body. It's a good habit to get into. So I'm going to go ahead and drag in this beam base into there. And now you notice it's going to not let me do it, right? I can't drop it in, and that's because it wants the object to be connected to be a rigid body. So I'm going to go to my beam base and make a rigid body here. And what we can do is we can make this really, really heavy so the player can't interact with it. And we can also freeze all the constraints, right? So it's just a stiff object in the world. So drag in our beam base there. And now the anchor and the axis. I'm going to go ahead and hit this little help button here, because this is really, this is all the information that best explains all these properties and everything that's going on, right? So the anchor, this is the position of the axis around which the body swings, right? So this is where it's going to rotate from, where this thing is going to hinge from. The axis, this is the direction of the axis around which the body swings. So basically, which axis is this rotating around? The X, the Y, or the Z, or some combination of the two. And both of these are defined in local space. So they are all oriented to this certain game object. So let's take a look at our object here. Get real close. Let me get this out of the way so you guys have maximum real estate. All right. So you'll notice, see this little arrow right here? This is showing me, one, the location of my anchor, as well as the axis in which direction it is. So see, right now it's going to rotate around the x-axis. So see here, my widget, this is pointing the x-axis here, down this way, as well as this object here. So if I go ahead and change this, say I want this to rotate around the y-axis, now it's pointing up. Here's that little orange widget there. It's pointing up. So now if I want to move this to where it's rotating from, you can start to adjust this. So you can actually, if you hover over the values themselves, or the X, Y, Z value, and click and drag, you can actually see the value change and watch the widget move itself. So if I put this at 0, 0, 0, it's going to rotate from that object's origin, right, from that 0, 0, 0 position. And if I put 1, it doesn't matter how big this object is. This is the value of 1, right? Because this is the end of this object. This is the 0 to 1 range. So halfway would be, 0.5, would be right in the middle. All right. So using these two, you can get this object to hinge from the correct location, or from the position you want. Bless you. So let's just test this out and see what it looks like. Let's make sure. Let's see, our object, we want to have this tagged as fizz, and we have a rigid body. Let's go ahead and see what happens. So right now it's rotating around the Y, not exactly what we want, but you can see that the hinge that it's rotating on is affecting it. So let's go ahead and stop this. Now let's try what happens if we do it in the Z, right? So think about it in terms of whatever direction the arrow is facing, it's going to spin around that object, right? So we want the object to rotate around the Z-axis, to swing up and down like it's attached to this base. So we want the Z-axis. And you'll see there's the widget right there. It's inside the geometry now, but it's right there, that little widget pointing alongside that Z-axis. And we want it to rotate from the middle point about halfway, so that looks to be good. All right. So That's behaving how we want it, right? But one thing too you can notice is I can just take this and fling it over. Should be able to just fling this completely around. Yeah, so it'll basically just break and not react. Because it's the connected body, it's able to pass through itself. And that's true if you have like multiple links. You don't want the links to prevent the other one from moving. So what we want to do is actually set some limits to this to prevent this object from moving completely all the way around. The way you can do that is right down here. So you'll see here is the spring, the motor, and the limits. Feel free to look into this more. Again, like some of the Unity documentation is really good and it'll explain some of this. And definitely test some of this stuff out yourself and look up some examples because there's only so much we have time to go over every class. But what I do definitely want to showcase is the limits. So to get any of these to work, you'll notice that these little check boxes here. So you have to check this on for it to work. Even if you set values in here, it won't matter if you don't check on these limits right here. So basically this is just allowing you to set a value of an angle of where this object can rotate from. Where are the mins and the maxes? So I'm just going to set a -90. So in case it ever gets completely flat straight into the ground, that's where it's going to go. But the ground will stop it from going that far. And then for a maximum value, let's try 60. So rotate at 60 degrees. And again, these are all local to this object. So right now it's at 0 degrees, and down would be 90. Up would be, this would be +90. Down would be -90.
Real quick, Andrew, like when well, I guess in our next class or next month, would we have to get like really detailed with like making a hinge and stuff and like explaining like how it can move like that? Do you want us to get that detailed like next month?
What do you mean, like putting like actual geometry there?
Yeah, like right now it's like 2 blocks magically going up and down.
Yeah, I mean you can definitely, like I'm just like prototyping some setups and interactions.
Yeah, I was asking what y'all were looking for.
In level design, you're going to come out of level design and your entire level is going to be level blocking meshes and basic assets. So it's important to think about that, and that's why I stress so much about having like a frame in your entryway, because you don't want to have just like a block sliding up or just sliding into walls. You want to actually think about how this is constructed. And now once this is functioning like this, we could actually go in and add the hinge, like a visual hinge later, right? It's just a visual object there that's representing where this is rotating from. But you could take this further and add more of that detail. The more you put in, the better off you'll be for sure. I don't think so. You guys are always trying to break the character. Oh, yes, you can. Cool. All right. So, and then you can see in the example as well, I just took I took another block. So I'm going to just make another level blocking mesh. And I just put this in here again. This is just to add a little bit more interactivity. So I'm going to make this a value of 2. That looks good. And I'm going to make this a rigid body. And make this fizz just so the player can move it out of the way. Let's go ahead and add another collectible. All right, so now the player can't quite just jump up here, right? They can't get up here, so they need to a little bit more interaction, right? Move this thing out of the way, and now they make a little ramp for themselves. So this could, tie into just collectibles and small interactions, and this could be something that you could think about for, player progression in some way, right? So there's a good example of a hinge joint. In this assignment, in the experiment, you'll see that I don't walk you through this one down here. Where is it? This one right here. But it's a lot of what we just worked on, just applied in a different way, right? So this was, I saw a lot of this in some of your levels where you have something that you tip over and make a bridge and walk across. that's using a hinge joint, right? So here you'll notice this red object, this is the connected body, so this could be like a tree trunk or part of a pillar. And then this one here, this blue object is the connected body, or sorry, this is the one with the hinge joint, and that's constrained and only rotates a certain direction. So try this one out on your own, and you can do this like off the side of your pedestal, like make a cylinder or another base and then tip this one over and try and get to it. So try that one on your own. It's pretty much exactly the same thing we did that we set up for this one. And then it looks like we got just enough time. So let me showcase the spring joint in a cool way to utilize this. So let's go ahead and create a 3D object. And I'm just going to guesstimate with some of these sizes. So let's try, so we want to make it, let's try 3 in the Y and 3 in the Z. Yeah, it looks about good. Okay, so what we're going to do here is we want to create some type of platform, and we're going to use a spring joint to give it a little bit of, bounciness and a little bit more interactivity for when the player steps on it. So here's our, I'm going to call this spring platform. Okay, so here we're going to add a spring joint to this. Okay, and once I add the spring joint, you're going to see it automatically adds a rigid body to it right here. Okay, so the next thing I'm going to do is I'm going to create an empty game object, and I'm going to pull this out, and I'm going to call this spring connected body, because this is going to be our connected body. So it's important that we put this in a correct location, because this is where the spring is attached, right? So if this is our connected body, we have a spring that's going to be bouncing in this connected body. Wherever this goes, the spring's going to go with it. All right? So I'm going to, and what's important to know is we don't need to parent these to each other, right? They just need to be separate entities. And with our spring platform, I'm going to drag my connected body into here. Actually, first, before I do that, I'm sorry, I'm going to move it. I want to get it above the object because I want the spring to be, let's try that. Or, I'm going to snap that object. Oh, yeah, not snapping, that's bad. Negative 2.5. Let's put this at 0.5 and negative 30. Okay, so now I'll take my connected body and move it up. All right, and then now let's go ahead and connect our connected body in here. And before we mess with anything, let's just test it out and see what happens. This should be fun. Nothing. All right, so, bless you. So on here, if I move, let me try moving both of these up. So there's the, okay, there's our widget. So we need to adjust the anchor. That's why. Nothing. This is the connected body. Here's our platform. Let's sit in the scene mode. See if we get any functionality at all. Let's see. So if I grab my connected body, no, not quite. Oh, I think I know what I'm doing wrong. We need to constrain. So the platform, we don't want it to move because we want our connected body to do the movement. We only want the platform to rotate. Let's try that. If I might do it. Let me move everything up. And then we just have to work on the getting the correct tension. So there we go. It's not moving. All right, that is, I think it's our mass. Our mass needs to be adjusted.
So it's like hanging over that screen.
Yeah, so this will be good for like having like crates or something like in in water, to where, oh man, that's real weird. Let me try removing the. So like this would be like crates like in the water, to where when the player jumps on them, they have a little bit of wobble movement to them, as well as a little bit of tension. We haven't gotten to the springiness yet, which I think I may have set this too high, which is why it's behaving erratically. Can't jump on it. Constrained. Oh, you're okay. So the position, that guy. Let me make this a little bit smaller as well, so I can get on top of it. Oh, there we go. So I think I need to mess with the tension of the spring a bit more. And this is so the platform itself, we want to freeze the position of it so the platform doesn't move. And the connected body, we want to freeze the rotation. And for this example, I'm having it frozen in the Y. So let me just play in game mode or in the scene mode so you can. So when I move my connected body, no. Time we got 3 minutes. So it's a little bit better. Definitely moving towards the right functionality. And we can now set it up to where our connected body is what's controlling the movement of the object. What? What? We're fine. All right. Well, we can mess around more with that. If you guys want to see more, I can show you the exact example and get it exactly where we want it to. But this is one way to create some type of movement with with platforms themselves. And another way to utilize the spring joint